In this video clip, we want to write the partial fraction decomposition for the given rational expression. This rational expression is one polynomial divided by another polynomial. We want to write this rational expression into the sum of two rational expressions. That's called decomposition of rational function or rational expression. Apparently, when we factor the denominator, x squared minus 5x minus 6, it will be like this. You see, negative 6 can be split into negative 6 and 1. Negative 6 times 1 is negative 6. Negative 6 plus 1 is negative 5. So denominator can be factored into the product of x minus 6 times x plus 1. We want to go further. We want to go how far? We want to go to decompose this rational expression into two parts, into the sum of two fractions. Okay. So basically here what we need is what here should be those a, b values we want to find out. Okay. And then, since this is the form we needed, I wrote it here, we copy it. How we are going to add those two? Well, this is x minus 6, this is x plus 6. So apparently the first fraction is x plus 1. So you do x plus 1 on numerator and the denominator. You make the denominator be the same. So for b over x plus 1, you need x minus 6 on both numerator and denominator. Once you get denominator, those two are the same, you leave it alone. You do is a times x, which is ax. A times 1 is 1a. Similarly, you do the distributive property for this one goes here, and for this one goes here. Okay, so bx and then negative 6b. Similarly for that. Okay. Now, then you should combine the like terms. Ax, bx, you pull x out. Then you have a plus b. A and the negative 6b, they are constants. So you put together a minus 6b. Now you see this a plus bx plus a minus 6b has to be the same with here 2x minus 5. So then a plus b must be equal to 2. So that's how we got the equation. And a minus 6b must be equal to negative 5. Okay. So if you have this kind of AB, you put here, then a plus b is 2, a minus 6b is negative 5, you are done. Then you have AB values correctly. So basically we need to do is we want to solve those system. And we know that here is a, here is a. So we do subtract equation above, subtract the equation below. We shall cancel a. So you do subtraction, you minus a, minus 6, minus 6b, you have a positive b, minus -5, you have a positive 5. A negative A will be cancelled. 6b plus b will be 7b. 5 plus 2 will be 7. Divided by 7 on both sides, b comes out, which is 1. Put it back here, and b is 1. Put it back here, a plus 1 is 2. Minus 1 on both sides, a comes out, which is 1. So basically, if you have a value is 1 here, and here is 1 as well, then when you add 1 over x minus 6 plus 1 over x plus 1, you'll get this one. Why do we need to do so? Is because this class is called pre-calculus. In calculus, when you are going to find out the indefinite integral, you need to separate this rational expression into two parts. And here, once you have those two parts, you can immediately find out the antiderivative. So that's why we need to get it ready. Write this rational expression into the sum of two fractions. That's why we need to decompose a rational expression here into the sum of two fractions. Okay? All right. I'll see you next time.